continue. Here's the video on decimals. We'll discuss basics of decimal numbers in this video. It's video number 17, part 1 of 3. I split the video in 3 parts and this is the first part. Okay, let's continue. Outline. This section is on decimal numbers and we do have 2 more sections. Next section would be add and subtract decimal numbers, and one after that would be multiply and divide decimal numbers. Okay, let us continue. So what is a decimal number? Let us see if we can figure out what decimal number is. First of all, what's decimal number? It is a number in decimal, which is 10 base. 10 base means digits 0 through 9. Number system. If a fraction, it's a fraction, usually a mixed fraction. Mixed fraction means has a whole part and fractional part. Okay, let's continue here. A numeric expression, which is like a monomial of one term. It's just like in a algebra, there are monomials. This is just like a monomial, a numeric expression, and has only one term. Okay, it doesn't. Okay, let's continue. Of 3 parts, whole number, fraction, and separator. So would have a whole number, fraction, and separator. Separator is the decimal point. Okay? Is coefficient and exponent. Just like in algebra, we have a coefficient and exponent, which is power of x. Here, exponent would be power of 10. Let's continue here. So, example 29.163 is a decimal number. It has a whole part, it's a fractional part, and a separator, which is decimal point. Okay, how about 69? It sure is a decimal number. It's within the 10 base system, has 6 and 9 from 0 through 9, and with the implied fractional value of 0. Where fractional value is not specified, its implied value is 0, which is a dot 0. Okay, let's continue. So this 29.163 is a decimal number, and so is a 69 with the 0 fractional value. 0 as a fractional part. Okay, let's see where decimal numbers come from. Okay, where the decimal number come from? Okay, as a fraction, it must come from division, and we have a video on fractions here. So this come, and this is the division here. Dividend is divided by divisor, and answer is quotient with the remainder at the end. Okay, let's continue here. So how is decimal fraction different from a count fraction? So in a count fraction, we did the division here, and then we say we had a quotient and a remainder, okay, and the answer. So, and fraction was equal to quotient with the as a whole part, a remainder divided by divisor as a fractional part. If a whole part was 0, then it was a pure fraction, and if whole part was not 0, then it was a mixed fraction. If remainder was 0, it was a whole number. Okay, let us continue here. So divisor is a natural base number. What difference is that divisor in the fraction was any number we can think of, and here divisor is a natural base number. Those are numbers like 1, 10, 100, 1000, and on fractional side is a 0.1, 0.01, 0.001. Decimal numbers and count fraction. Let's try to compare them. Okay? How is decimal fraction different from common fraction? Okay? And divisor is natural base number. That's what we studied in the previous slide. Okay? Have you divided by natural base number? So we would have to divide by natural base number. Okay, and in fraction we were dividing by the divisor. Here divisor is a natural base number, and have you divided by natural base number? Okay. Sure, you have done that before. In 3 methods of division we discussed before, we use 2-step division. Example, here's one example, nickel method of division. So we first divided by the base number and then by proportionality and made adjustments. Okay, the steps were divide by base number, divide by proportionality, and adjust. Okay, that's what we all 3 methods here discussed in division. This is one of the example is, and this is what we did: divide by base number, then divide by proportionality, and adjust. Okay, adjust for what our deviation is. Let's continue. Do you recall how did we divide the base number? So let's divide by base number. Okay. You do you recall how we did divide by base number? Okay. Continue here. Let's say the number was 538414. We are dividing by 1000. 1000 is a base number. What we did, we draw a line to the left of a 3 digit. 3 digits come from number of zeros in the base number. Okay, and we said that if you were dividing 538414 by 1000, then 538 was the quotient and 414 was the remainder. And also 538 is the whole number and 414 is the decimal fraction with the whole number. So this would be a mixed fraction, 538 as a whole number and 0.414 as a fraction. Okay, so we dividing by 1000, which is base number, is moving the decimal point from the implied position of rightmost position to 3 position to the left. So move the decimal point from the implied position of the rightmost position to the 3 positions to the left. Okay, so that's how we divided by base number 1000. Let's continue here. So that's 538.414. Okay. But that means 538.414 is 538.414 divided by 1000. We got 538.414 we got from here. So that's what it is. Okay. And 1000 is 10 times 10 times 10, which is a 1 times the power 10 raised to the power 3 or 10 cubed. Okay, so in the denominator. So that is equal to, if you say that in the numerator is 538414 times 1, which is a 10 power 0 divided by 1 times 10 power 3. Okay, then that's x to 0. Just like in algebra, that's like x power 0 and 1 times x cubed. Okay, where x is equal to 10. Okay, let's continue here. So that we did say that we're going to divide the coefficients in here in algebra video. 538414 divided by 1, which is 538414, and we subtracted the flag values. Flag is 3 here, flag is 0. 0, 0 minus 3. Flag in the numerator is 0 and flag in the denominator is 3. We subtracted the flag of the numerator. From the flag of numerator, we subtracted the flag of the denominator. 0 minus 3. So and the result was, okay, so that's it of the form coefficient times the exponent. This is the coefficient part and this is the exponent part. Okay, and a decimal number is similar to an algebraic expression. This is, okay, so decimal number is similar to an algebraic expression. It's a, in algebra they are monomial, binomials, trinomials, etc., and polynomials, and a number decimal number is a monomial. Okay, let's continue here. Decimal number is a numerical expression. Let's see if we can add zeros to the decimal number. Okay, how you added zeros to the right of decimal number? Do you remember that? Answer: you should have done that and have done that without a second thought. It was in divisions when we were decimalizing the results. When we were decimalizing the results, we kept adding zeros to the right and didn't even think about it. Okay, let's continue here. Example: in nickel method division, we computed 1 over 13 via 3 divided by 39. We continued dividing past 0. Okay, and by adding zeros. Okay, because 1 divided by 13 was 0 and the remainder was 1. Okay, let's continue here. Question: does that change the value of decimal number? When we add zeros to the right of decimal, does that change the value? Question: what does adding a 0 to the right accomplish? If you did add a 0 to the right of the number, what happens? Answer: it multiplies the number by 10. When you add a 0 to the right of a number, that multiplies the number by 10. Okay, let's continue here. How do you keep number from changing its value and still add zeros to the right? Now we want to add a 0 to the right and still keep the value same, which is equivalent value. Okay, let's continue here. How do you do that? If you simultaneously divide by 10 also, then you would have achieved that kept the integrative number and still added a 0 to the right. Okay, so let's say consider number 25.12. Okay? So we want to add a 0, and this 25.12 is like 2512 divided by 1000, which is like 2512 times in the numerator 10 power 0 and in the denominator divided by 10 squared. Okay, let's continue here. So that's like 2512 times 10 power minus 2. We subtracted the flag values 0 minus 2. Okay? 2512 divided by 1, denominator had a 1 times, and so which divided the coefficients of the numerator by that of the denominator and subtracted the flag value of the denominator from the flag value of the numerator. Okay? So that is equal to, now we're going to multiply and divide by 10. Multiply by 10 in the numerator and multiply by 10 in the denominator. Okay? That's equal to, which is equal to 25120 divided by 1000. Okay? So we took the number here, we multiply by 10. Okay? And that's like 25. When you divide by 1000, it's like moving the decimal point from the implied position to the rightmost to 3 position to the left. There are 3 zeros in 1000. Okay? Which equals 25.120. We just added a 0 and we still have the same equivalent number. In 25.12, we added a 0 to the right. We achieved that by multiplying and dividing by 10. So that means we did not change the value. It's equivalent value. So 25.12 is equivalent to 25.120. That means we can add zeros to the right of decimal point. Okay. If the decimal point wasn't here, we couldn't add a 0 without changing value. But if decimal point is here, we can keep adding zeros to the right. It does not change the value because that implies multiplying and dividing by 10. Okay, let's continue here. So that's equal to 25120, like just like the same one, 1000. Okay? And that's equal to 25120 times 10 raised to the power minus 3, which is a coefficient is 25120 and exponent is 10 to the power minus 3. Okay? You have minus 2 here, now you have minus 3 here, the 2512 here, and 25120 here. Multiply this thing by 10, 25120 coefficient multiply, and also divided by 10 by subtracting a flag value from here, 10 power minus 2 and 10 power minus 3. Let's continue here. By adding it to the right, we reduce the exponent power of 10 by 1. We reduce the exponent power and we added a 0. Okay? Let's continue. By adding 0 to the right, we can change the exponent or the flag value. So we just, when we add the 0 to the right, we are changing. Let's look at references. The first reference I use is Vedic Math Teacher's Manual 1, Volume 1, which is a elementary level by Ken Williams, and this book is available from vedicmaths.org. PDF form is free. The book does not have a section on decimal numbers, but it's assumed that you can use the techniques described in the book for decimal operations. Let's continue here. Vedic Maths by Bharti Krishnaji. This is the main primary reference on Vedic math, and it covers all the topics in Vedic math. And the book may not have a section on decimal numbers, but it implies that user is familiar with decimal numbers or can use the other techniques described to compute the user decimal numbers. Okay, let's continue here. Discover Vedic Math by Ken Williams. This is the most complete, authoritative, and with consistent notations. Book is organized by sutras. So this should have section on decimals. Okay. Let's continue here. Vedic Math for School in 3 volumes by James T. Clover. Mr. Glover used these books in his school. It is easy to read, very complete, not as complete as Ken Williams' book is, but it's very complete and contains significant geometry. So if you need to learn geometry too, as is taught in schools, this book is a very good reference. Okay, let's continue.